Alright, welcome back guys. We're going to look at section 9.5. And guys, by the way, we're nearing completion, just so you know, in case you're getting distressed. We still need to cover 9.6 and then 9.7. But we're going to do half of 9.5. Now the crux of this section, guys, is dealing with or using these properties of logarithms. Okay, but before we look at some of those properties, we're going to kind of review some exponential properties, because if you remember, that's what a logarithm is. It's an exponent. When you're trying to evaluate a logarithm, you're trying to figure out the base of the logarithm raised to what power gives me the argument of the logarithm. So you're trying to figure out that exponent. That's what a logarithm is. Alright, so the first one we're going to call product rule. You guys should be familiar with this. It just says that if we have these two exponential expressions and we are multiplying them and the bases are the same, so the bases are both a's, then you add the exponents. Okay, so x to the second times x to the third is x to the fifth. And we've got an example down here. And it doesn't matter the number of exponential expressions you have. If the bases are the same and you're multiplying them, then you just add the exponents. And so this is going to give us a to the, well, if I add these exponents, 8 and 4 is 12, with negative 5 will leave me with 7. So this will become a to the 7th power. I'll point out that this negative exponent right here, if you were trying to simplify this, you could think about it like, well, I would have a to the 12th on top. This factor here could move down to the bottom and become a positive, and if you were to divide out your a's, you would have 7 left over. Okay, that's actually what this next rule says, the quotient rule. It says that if you were dividing two exponential expressions, then you can simply subtract the exponents. Okay, similar to how I did up here. 12 minus 5 is 7. Okay, so you subtract the exponents. Alright, so example 2 here, it says divide and simplify. Well, we just need to figure out what 8 minus negative 5 is. So we're subtracting a negative, so that's the same as adding a positive 5. And so this will yield x to the 13th power. Another way to think about this one is you could move this x to the negative 5th up to the top and it would become a positive 5. Then you could use product rule to obtain x to the 13th. Okay. So when you're evaluating these expressions, there's more than one root that you can take. Alright, and then the last one we'll look at is power rule. So this says if you have an exponential expression and you're raising it to a power, then you multiply the exponents. Okay. So an example here would be if I have x to the second and I'm raising that to the third, and that will become x to the 6th. And the reason is because what does this 3 mean? Well, this means x to the second times x to the second times x to the second, which then, if you use product rule, is x to the 6th, because you're adding 2 3 times. Now, that's what multiplication is, right? Just repeated addition, essentially. Alright, so let's apply this to example 3. It says multiply and simplify. So here what we have, guys, we've got some powers, and these powers affect the factors that are inside these parentheses. Another way you can think about this is you can say, oh, okay, well, the 4 and the y, they have exponents of 1, So if I multiply those exponents by this 2 on the outside, then they'll have exponents of 2. In other words, it's like you're distributing this exponent 2. It affects both of those factors times, and then I can do the same thing over here. This will become 8 to the third, y to the third, and then I can simplify it, okay? Well, 4 to the second, that's 16. 8 to the third, you might have to use your calculator on this. I believe that that's 512. Okay. And then I just keep going. Actually, I miscopied an exponent. Here we go. And I think I'm going to have to get a calculator for this. 16 times 512. Oh, let me show you guys real quick. There's an online version of this TI-84 emulator app. If you type in TI or just do a search, I'm looking for computers, folks. So inconvenient. Okay, here we go. Well, I'm frozen. That's okay. Yeah, if you type in TI-84, or just do a search, let's see, here it is, TI-84 calculate.net. You can find this, and we just launch it right here. Okay. Now I'll type in there 16 times 512, and it's 8,192. And then here, y to the second times y to the third, well, you add those exponents, and you're going to get y to the fifth. Okay. Alright, now let's look at example 4. Same thing here, similar. The difference, though, is that these factors x and y, they already have exponents, and so we're going to be multiplying those exponents by this 4. Okay, so in other words, if I distribute this 4, you can think about it that way. This will become 3 to the 4th power. X to the 4th here, raised to the 4th. You're going to multiply those exponents. 4 times 4 is 16. And then furthermore, y to the 3rd raised to the 4th, you multiply those exponents, and you're going to get y to the 12th. And then the last thing I can do here is 3 to the 4th is 81. I cannot add the exponents here, guys, because these bases are the same, or not the same. Okay, so this will be my simplified expression. Alright, so now we're going to see some logarithmic properties that are basically derived from these exponential properties. Okay, so we're going to have a product rule for logarithms. But these properties are kind of going backwards. So with an exponential expressions, when you're multiplying two exponential expressions, you add the exponents. Well, think about this. These logarithms are basically exponents, and so we're adding them right here if you're looking at this property. And then if you come over here to the left side, these exponents are being multiplied in a sense, okay? Or the exponential expressions are being multiplied. So the way you can think about this is, if you're taking the logarithm of a product, or two things being multiplied, then you can split this up into two logarithms by adding those two factors, okay? So it's basically this product rule right here backwards. Okay, it's kind of like you're starting right here on the outside, and then you're moving back in. Okay, so in other words, if you're taking the logarithm of a product, then you can separate that into two or more logarithms by separating the factors of this product. Okay, m times n. And so example 5 says express as a sum of logarithms. Well, that word sum connotes addition. Okay, so if I use this product rule up here, this is going to become log base 7 of my first factor. This is kind of like my m. And then the 21, or the second factor, is like my n. Okay. So this will become log base 7 of my first factor plus log base 7 of my second factor. Okay. So what we have done here is we have expressed this original logarithm as a sum of two separate logarithms. See here? As a sum. Alright. And we could go the other way as well. You know, we could put these back together and get 13 times 21 for our argument. Alright, we're actually going to exploit that in example 6. Because example 6 we're kind of starting on the right hand side, the two logarithms have already been separated, or they've been written as a sum of two logarithms. And so we're going to rewrite them as a single logarithm. We're going to put them back together. So the base of our logarithm is going to remain w, and then the 10 and the 15 will become the factors of the argument over here in the logarithm. So, well, first I'll kind of explicitly write this 10 times 15. You know, so this is like our m, this is like our n, so it becomes m times n. And we could simplify this as well if we wanted to. 10 times 15 is 150. We could carry this out and say this will become log base w of 150. Okay. So that's an illustration of the product rule. We're going to get a fair amount of practice later on in the part 2 video. We apply these rules of logarithms to completely expand or condense some logarithmic expression. Okay. All right. Well, that's the product rule for logarithms. So when you see or think of product rule, think about addition. I'll even kind of write this in the notes here. Okay. Now, similar to how we had a quotient rule with exponential expressions, let's actually do that one next, and then we'll go back to this power rule. Similar to how we had a quotient rule for exponential expressions, so if you remember, you had a to the m divided by a to the n, you would subtract those exponents. Okay. Well, here the quotient rule for logarithms is if you have a quotient, if you're taking the logarithm of a quotient, then you can split this quotient up using subtraction. Okay. So this will become, you'll keep the base of the logarithm the same again. Log base a of the numerator minus log base a of whatever that denominator is. Okay. So example 9, it says express as a difference of logarithms. Well, that word difference, if you remember, means subtract. Okay. So this will become log base r of our numerator, which is a, minus, okay, log base r of our numerator, which is b. And so that's it. I've expressed this logarithm right here as a difference of logarithms because the argument of this logarithm was a quotient. So that's why this is referred to as quotient rule. Now you can go the opposite direction as well. If you have, now I'll give you an example because I don't think we do have one. Yeah, we do have an example in number 10 here. We have two logarithms that are already separated with subtraction, so we already have a difference of two logarithms. Well, we can condense that down into a single logarithm, okay? Similar to how in this previous example we started out with a sum of two logarithms and we condensed it down to the logarithm of a product using the product rule. So now, down here, we're starting out with a difference of two logarithms, and we can condense this down to just one logarithm of the quotient of these two arguments. Okay. In other words, the 1,000 becomes my numerator of my quotient, and the 10 becomes my denominator. And then we can simplify this further. You can divide 1,000 by 10, and that is 100. So this will become the log, or the common log of 100. And remember, this is a common logarithm. So although the base is not written, we understand it to be 10. It's understood to be 10. Okay. And so you can evaluate this one by hand if you want. You can think, okay, 10 to what power is equal to 100? Well, 10 to the second power is equal to 100. So all of this condenses down to just 2. Alright. Well, let's look at one last example, or look at this last property of logarithms, and then we'll put all of this together in part 2. Okay, so the last property is the power rule. Okay, so the power rule corresponds to the power rule with those exponential expressions. Let me find it. So it said that if you're raising an exponential expression, so you already have an exponent, raising it to another power, then you multiply those two exponents. Well, with logarithms, here it is, yeah. So the power rule with logarithms says that if you have a logarithm of an exponential expression, or in other words, an expression that already has a power, so in this case p right here, then you end up multiplying the logarithm by that power, p. So it becomes p times log base a of m. Okay. In other words, the way I look at this, guys, is you can take that power and just move it out front. Okay. So this becomes 5 times log base x of e. Okay. That's what it means when it says express as a product. The product means multiply, so this ends up becoming 5 times log base x of e. Sometimes, too, you'll be able to simplify this logarithm right here, and so you'll end up being, you may end up getting just some number here, and so you multiply that by 5, and you can simplify it even more, but not in this case, okay, because the base of this logarithm is actually a variable. Alright, now we can go backwards as well. Well, we're not going to go backwards yet, but you can go backwards. So if there's a number in front of your logarithm, you know originally that number was the exponent of the argument. Okay, so log base x of e to the 5th. Alright, let's look at example 8. This one says expresses a product. So this is the natural log of the square root of 15. So you may be wondering, well, where's the exponent? Okay. Well, you've got to remember that property that we talked about last class. Oops, let me not use an A there. I'm using X. Okay. If you have the bth root of x to the a power, and you can, or in other words, if you have a radical, you can express a radical expression. You can express that radical expression as an exponential expression, and this becomes x to the power of a over b. Okay. Hopefully you vaguely recall this from 9.4. And so knowing this property right here gives us a way to re-express a radical expression as an exponential expression. So in other words, I can rewrite the square root of 15 as 15 to some power. I just need to figure out what numbers are filling the roles of A and B. Well, the square root, we know that the index is understood to be 2, and then anything has an understood power of 1. Okay, so this is really the same thing as the second root of 15 to the first. And knowing that, then I can re-express the square root of 15 as 15 to the 1/2 power. So that's my first step here. So this is really the same thing as the natural log of 15 to the 1/2 power. So now that the argument in my logarithm actually has a power, now I can apply this power rule. Okay? Or in other words, I can essentially move that power out in front of the logarithm. So this becomes 1/2 times the natural log of 15. So that's my product right there. Okay. So we got 3 properties, guys, that we're going to be using exhaustively in the part 2 video. We've got this product rule that allows us to split a logarithm up using addition. Okay, if the argument of that logarithm is a product, or condense it. And then we've got this quotient rule that allows us to split a logarithm up using subtraction if the argument of that logarithm is a quotient. And then finally, we've got this power rule. It basically says if we have a logarithm of something with a power, we can move that power out in front. Okay. All right, now in the part 2 video, we're going to do 2 things. We're going to be given a logarithmic expression, and we're going to expand it into several logarithms using these properties up here. Then we're going to be going in the opposite direction. We'll be condensing a logarithmic expression, so we'll have several logarithms, and we'll condense them down into just one. So we'll be going in the opposite direction. Okay, so we're going to get a lot of practice using those properties, those 3 properties, in the part 2 video. Alright, well, I'm going to stop for now.